This webinar is sponsored by NEC Corporation, a $37 billion technology leader with over 100 years of innovation. Their Programmable Flow Network Suite was the first commercially available enterprise-class SDN solution to leverage the OpenFlow protocol. Thank you for your time and interest in NEC's Programmable Flow Network Suite.
This sponsored webinar is one of many IP Space Data Center webinars. You can register for live sessions, buy the recordings, or get access to all of them with a yearly subscription. For more information, visit ipspace.net/dc. You know that Layer 2 networks have serious scalability constraints. And it's not just the spanning tree. We're not discussing spanning tree here. The problem is that Layer 2 forwarding relies on flooding of multicasts and unknown unicasts. And because the hypervisors, particularly if you work in virtualized environment, the hypervisors have to put their physical NICs in promiscuous mode, all the hypervisors will get all the flooded packets, so you will burn the hypervisor CPU. Unfortunately, people use a very common design where they configure every VLAN on every server port just in case, which means that every hypervisor gets multicast for every single VLAN, even if the hypervisor has nothing active in that VLAN. And some marketing people are promising you heavens on earth, and people writing standards are more realistic. They're saying, well, honestly, the current broadcast domains can support around 1,000 end hosts in an environment of around 100 bridges. This is straight from the Trill RFC. And if you have every VLAN on every server port, because of the amount of broadcast you're generating, you're actually talking about 1,000 VMs. So we definitely need some scalability tools. And the first thing, and yet again, this is an extension of OpenFlow. OpenFlow has nothing like this, is policing of flooding traffic. We are monitoring the internal ports this time. And if we're getting too much flooded traffic from the internal ports, we start to drop it. Remember, this is the external port, this is the internal port, so we would be monitoring internal ports only. And if A is sending broadcasts toward B, then this might be the potential monitoring points. And if different broadcasts are arriving to this switch, then they would be added together, so we are monitoring the aggregate of all flooded traffic. The match conditions are ignored, so we are only interested in flooded traffic. And we can either set a priority or drop it. So these are the two options. And by the way, this only works on the edge switches on PF5240s, even though in theory this would be the internal ports where you could do the flooding policing. You cannot do it if you use 5820s as the core switches. The question I got before was, okay, so how does an OpenFlow network handle unknown unicast flooding? For multicast and broadcast flooding, it's simple. When a virtual tenant network is configured and we know where the external points are, we can pre-configure the flooding trees like in traditional spanning tree. And the broadcasts and multicasts would be flooded along the spanning tree from every ingress switch toward the rest of the network, obviously controlled by the vExternal interfaces of the vTenant network. But what about the unicast flooding? Actually, the unicast flooding has to be done through the controller. So let's say A is sending a packet to X, and we haven't seen X before, so we have no idea where X is. The switch can do nothing else but to send the packet to the controller. And now the controller also doesn't know where X is. It hasn't seen it before. So it has to emulate layer 2 behavior and flood this to all the other vExternal interfaces on the same virtual tenant network with packet out messages sent to all the other switches participating in this virtual tenant network. And so you are actually doing unicast flooding through the control plane, which is a bad idea. But this is how it works, and there's not much we can do. However, we can apply shaping on ingress OpenFlow switch. Yet again, this is an extension to OpenFlow, and this prevents too many unicast packets from being sent to the controller, so at least you are protecting the controller from the unicast flooding, and you are protecting the communication channel so that you don't saturate the SSL session with unicast flooding. You probably know that one of the major sources of unicast flood are the situations where the ARP timer is bigger than the MAC aging timer and you have unidirectional traffic. MAC addresses expire in the controller and in the switches, and because A is only sending the traffic to B and not receiving any traffic back from B, so B could be, for example, syslog host. No one knows where B is, but because the ARP timer hasn't timed out yet, A would not send another ARP request, so no one knows where B is. And we are back to unicast flooding. And you can configure ARP snooping and ARP refresh on the ProgrammableFlow controllers. ARP snooping is obvious. All the ARP requests go also to the ProgrammableFlow controller. It has to listen to ARP requests anyway, so that it can answer when someone is asking for the MAC address of the virtual router. And so with ARP snooping, PFC now has complete IP to MAC visibility. And when someone is sending packets toward B, and B is an IP destination, but its MAC address is unknown, then PFC can send an ARP request for B. It knows B exists because it has complete visibility, but it doesn't know where B is because the MAC address aged out, but it can trigger an ARP request, and so B will respond, and now we know where B is. So with this, we can get rid of most of the anomalous unicast flooding, but of course, if someone wants to configure something like Microsoft Network Load Balancing, where flooding is built into the system, then there is nothing you can do. Is ARP also multicast? Well, we handle broadcasts and multicasts the same from the flooding perspective, but obviously PFC would only listen to ARP requests, and with OpenFlow you can match on ARP packets specifically. Does it mean we can build some rules to manage the multicast trees? So Samrat, can you specify how the multicast tree will be built, over which particular physical links it will go?
PFC can proactively or does proactively build both the broadcast and the multicast trees, and it is done actually in the time when the VTNs are getting deployed into the network. And then after that, based on the matching criteria on the multicast address space or the broadcast address space, they can be routed to the trees. Typically, these trees are shared trees, which essentially connects the switches and the ports on that particular tree.
Is there no hybrid mode in the non-intelligent forwarding devices to start using ARP and normal protocols if PFCs suddenly break? No, you can't have the virtual tenant networks in the PFC and then revert to whatever if the PFC should break, because that could create security problems. If you have questions after watching this video, send a tweet to @iOSHint. Or send me an email using contact form on ibspace.net, where you'll also find information about other data center webinars. For all commercial questions and programmable flow evaluation requests, please contact NEC.